have heard the term neural networks a million times. But what exactly is a neural network? Like, how can a bunch of math and code predict stock prices, in fact, recognize cars, cats, dogs, and in fact, predict the weather tomorrow? Like, how can it do all of these things? And today in this video, I'll exactly explain how and what a neural network is. How does it even function? What is the sense behind it? What is the science behind it? What is the logic behind it? Right? Even before diving into the code or using any special libraries of Python like TensorFlow or PyTorch, we will just use bare bones maths and logic, right? And we'll try to understand the theory behind how these neural networks actually work. Like, it's highly inspired from our own biology, like the nervous system of our own body, but yet why is it so simple yet so complicated, right? So this video is all about neural networks, the theory behind it, and obviously at the end I'll walk you through the whole code of me writing a neural network completely from scratch without using any, what do we say, the data science libraries of Python, TensorFlow, PyTorch, any of those. Just simply pandas, numpy, matplotlib, and that's it. That's what it is in this video. Okay. And in fact, just as a special tip, whenever you are learning something kind of like this, okay, this neural network topic, I would highly focus on the theory, the intuition behind that particular topic, rather than simply delving into the code and just making you understand some simple lines of code written in English, and that's it. That's not how my approach is while I am teaching. Okay, my approach should be always like, okay, I'll explain the theory behind it and then maybe we can walk through the code. Because if you have understood the theory first and then you walk through the code, the topic becomes crystal clear to you. Alright, so without any further ado, let's deep dive into neural networks. Okay, so imagine this. Let's say I have given you a photo of a very old person. Alright, and let's say the age of that person I am not yet telling you, and the job is yours to actually find out the age of the person from that particular image, right? What exactly will you do at that point? You'll basically look at that image and see. You'll actually find some features or maybe some patterns in that images. Let's say the wrinkles on the face, right? The structure of the face maybe, okay? The color of the hair, as well as the clothes even sometimes, right? While we are doing this, we don't subconsciously, try to calculate the numbers or something like that. We just see some features and then we just make a bland guess, okay, that this person might be in this range. Let's say if that person has some kind of wrinkles on his face and the hair is a little bit of grayish, we'll actually say that, okay, this person is a little bit old, maybe in the range of 50s or in his 60s or even in his 40s instead. Okay, and in instead, if the person has a little bit of prominent cheeks, no wrinkles on the face, a little bit of more steep features on his face, then we can actually say that okay, this person maybe is in his teens or something like that. This person is kinda young, right? So these are the features that you notice in an image subconsciously. You don't do this to yourself every time, right? It all works inside your brain. Okay, and this is something how the neural networks work as well. Like, let's say you actually find out those patterns, right? When you were finding out the age of that particular person in the image, you were looking at some patterns subconsciously, but you were looking at some patterns, right? But in the similar fashion, a neural network does the same things. It actually looks out for some patterns in the particular image that you give it as input, okay? And then based on those some patterns, it does some math, applies some logic, does some calculations, and then gives out a particular output. Okay. So from this whole analogy, what can you actually decipher? Okay. So we actually got 3 stages of how a neural network actually works. Right? The 3 stages are the input, the processing, and the output, right? The input is where you give it the image based on our analogy, where you give it the image. Then the processing is like where it does all those calculations, finds out the similar patterns, right? And in the output, it basically gives out an output that, okay, this is the, maybe this is the range or this is the age of that person. I have predicted this, correct? So these are the three stages of how a neural network actually works. To keep it in more technical terms, right, we'll call these layers. The three stages, we'll call these as layers, right? The input part, we'll call it as the input layer. What we do in the input layer, we basically give some images, some kind of a data, anything like that. We'll come that to later. Like we'll come to each individual layers a little after this. All right. The processing part. Now, whatever thing is going inside the processing part, we don't know. We don't know yet. So we'll call it the hidden layer. We don't know what's going inside. So we'll call it the hidden layer. Okay. And lastly, the output part, where the computer basically throws us an output that, okay, I predicted this kind of an output. Might be correct, might be wrong, might be completely different, might be completely alien, but yeah, this is my output. So what we will call it? We'll call it the output layer. So again, to recall, what are those three layers? Input layer, hidden layer, and the output layer, right? Okay. Now let's come to each of these layers one by one, right? Firstly, the input layer. As the name suggests, we basically gave some kind of an input to the model, and based on that input, our model will be doing the processing on it, right? Now the input, this input can be of any type, like legit any type. It can be text, it can be imagery, it can be visuals, it can be audio, it can be anything, okay? But in this input layer, there's one more small step that we do. That's called the pre-processing layer. Pre-processing, as in, basically when, let's say I only understand English, okay? And my audience is French. Now you give me a dialect to say, maybe a dialogue to say or something like that, okay? Will I be able to say that? No, right? I won't be able to do any calculations, any kind of processing on that, because I don't know your language. I don't know what you're speaking. I don't know whatever it's coming out of your mouth. It's not in the form that I understand, right? So that's what computer does too. Like computers don't know what is an image. It just understands pixels. Computers don't know what is an audio. It just understands, okay, these are the bits, these are the bytes, and that's how it works, right? So in the pre-processing part, we actually, pre-process the whole data. Like maybe convert it into a form that the computer understands. Like don't, overcomplicate it. It just converting our human readable data into something which the computer understands. Maybe cleaning it up as in, let's say, a data set. Now what is a data set? Data set is like anything that contains data. Let's say your Instagram chats, your WhatsApp chats, an Excel sheet, a diaries page, your register copy, anything like that. Now the data might be sometimes empty in some fields. Like let's say you have a Excel sheet of 1000 rows and 500 columns. Not every cell is filled, right? Let's say you have some inactive fields, some empty fields, some unrecognized character, something like that. So we clean up those data, maybe convert the whole data into something like more of a structured form so that the computer understands it properly. Okay, so this was all about the pre-processing part. This comes right inside the input layer. Like just before we pass the data into the computer, we pre-process the whole data set, right? The input layer is done. Okay, now comes the hidden layer. Now the hidden layer is where the whole magic happens. Here's where the neurons actually start doing their own work. Yes, I said neurons, not the biology ones that we have inside our body, not that. The ones from the neural networks. The whole idea of neural networks and everything is highly inspired from our own biology, as I said in the intro part, right? So the scientists that actually created the neural network mechanism and the architecture and all those fields, they actually termed the smallest part, like each individual nodes in a neural network, as a neuron. Okay. Now I'll talk more about the hidden layer after I've explained all the three layers briefly to you. Okay, because this is the part where the actual math and logic does their magic. Okay. Lastly, the output layer. Now the output layer is pretty self-explanatory. Like whatever output it basically generated after pre-processing, processing, doing the things on the input that we gave it basically, and then whatever the output comes out, it basically throws out to the user that this is the output that I have got. I have, after doing all my complex calculations and everything like that, this is the output that I have got. Okay, these were the three layers, the three basic stages in which a neuron actually works, or let's say a neural network actually works. Okay, now comes the hidden layer. Like what exactly is this hidden layer? Well, inside the hidden layer, when we pass the image, okay, let's say we have given the image, let's stick to our analogy of predicting the age of a person, right? We pass in the image. Now before passing the image, like before testifying it, you actually need to train the model, right? Like when a newborn child actually comes into this world, he or she actually sees the whole world around itself, right? Captures images through his eyes and then processes inside its brain. So it's basically training in an environment that okay, this is how an environment in a real world looks like. In a similar fashion, we also need to train our models as well, train our machine learning models as well. And that training is not possible using only one image. Let's say for example, when you were learning ABCs for the first time, was it like you just knew what are ABCs on day one itself? Just by looking at those how A is written, how B is written. Did you just understand that this is A, this is B? No. It took you several efforts, several attempts, right? In a similar fashion, machines also learn in a similar way. Before even predicting, like before even using that model to predict someone's age, we actually feed the computer, let's say 1,000 or 1,000,000 images of similar age group along with their actual ages, so that the computer understands, okay, if I have wrinkles, if I have this kind of a facial structure or this kind of features on the face, this is the age group that I belong to, right? I have fed in 1,000 images to that. Done. The model training is complete. Now I'll test the model. Okay. I took one image and then I fed it in the model and I told the model that okay, now calculate the age of this person. Right? What the model will do? It will calculate an age. Not even the age. It will calculate a number. Because see, for the model, the image that we gave in, it's all pixels, right? It's all pixels, pixel values, because they range from 0 to 255. Because yeah, the color codes and all those stuff, that's a different topic. But yeah, understand this thing that pixel are just numerical values, because in an image, there are nothing called images for a computer. It's all maths, it's all numbers, right? So it will do some matrix operations. Matrix, by matrix I mean those square brackets where we write inside basically the numbers inside, the row column matrices, all those stuff you have studied in elementary school, right? So this is what it is. Okay, the numbers actually get, they pass through some kind of an operations and then a similar some kind of an output. Let's say 0.001 came out as an output. Okay, and the output level that has been given for that particular image, which I gave it from my forefront to the computer, has some kind of an output, let's say 0.05. Now 0.05 says that okay, if an output is above a certain level, let's say above 0.5 the person is young, below 0.5 the person is old. Like let's say this kind of an analogy we are working on for that particular image. Now the image that I have given, the output is 0.05, right? And the output that it came up with is 0.0001, right? Now it's far from the output that I wanted. Like you see the error margin, right? Okay, so obviously it will basically generate some kind of bogus output, something which is not desirable. Okay, what we will do now? So this kind of an error margin, the error margin that we got from here is actually given us by something called loss function. Why is it called the loss function? Because some kind of an information was actually lost while calculating the error, right? 0.05 is the desired output and we got 0.0001. So much, the difference of the desired output and the calculated output, it actually got wasted. It actually went in vain, right? So that's called the loss function. The loss function actually tells us that, okay, this is the error margin of your model, right? Now what we will do? Now the machine is like, okay, I made mistake. I'll rectify it. How will it rectify? It will take the error margin, like it will take the error margin that we calculated and it will use to update weights. Now what is a weight in a machine learning model? Let's say when we were actually seeing the image and we were predicting on our own, like what can be the age of this particular person? What we were doing? We were actually prioritizing some of the features on the face, right? Let's say we were prioritizing on the wrinkles more than the facial structure because the wrinkles were a little prominent for us, right? And based on that priority, we said that the person is old. Okay? Might be that the person is suffering from a skin disease or skin defect. So that, and for that particular reason, the person might not be old. Okay, we might get a little, confused over here. That okay, that person has wrinkles on his face, then I must say, okay, that this person might be old. May not be that that person is not old. It might be makeup or something like that. Right? So, the priority that we give on certain features is called a weight in machine learning technicalities. Right? And same goes for the machine learning model as well. While learning the features, while learning everything, the machine was saying, okay, the wrinkles, okay, I'll see I saw the wrinkles, the face structure is good, so I'll go with, okay, this person is old. Might be that person is not old. And that's why the error actually came out here. So what it will do, it will update its priorities. It will update those weights. So this time, in this iteration, while the machine is again trying to predict the correct output, it will actually pay more priority on the facial structure as compared to the wrinkles, because wrinkles didn't give out a proper answer. It gave out a non-desirable output, right? And I am just talking about here two features. On a human's face, there are thousands of features, thousands such features, like the eye shape, hair color, nose, bone structure, everything like that, right? So the machine goes these so many iterations of this. Okay, like first it predicts an output, it calculates the loss function, and then again it updates its weight, and again it goes through the whole process. All in an attempt, all in the desire to minimize the error as far as it can go. Let's say it tries to attain absolute zero error margin, right? And who tells the machine that you're close to the absolute zero error margin? The gradient descent. You have heard of this term, the gradient descent. Now what is a gradient descent? Well, if we plot a graph, let's say you have a graph, okay, and you have a curve like this, a U-shaped curve, okay. On the top of the U is the error margin that you have currently, and the bottom of the U, where the U actually touches the x-axis, is the global minima or the zero where you need to reach, right? Now gradient descent is what? As you update the weights and as you calculate the outputs which are likely to minimize the error, we actually go step by step towards the absolute zero error, right? This is what we'll go through, okay? Now this gradient descent, in layman terms, it's just slope. We have studied slopes of a curve, right? Slopes of a graph, okay? And descent means going one step at a time. So this is what it is. Gradient descent is like just a graph which tells the machine that, okay, you are this many steps close to the absolute zero, right? But this whole process is termed something, right? I talked about two stages, I guess. Yeah, two stages. In the first stage, the machine actually picks up an image and it does some kind of a calculation and then it gives the output. The first iteration, it's called the forward propagation. Forward propagation, again I'm telling it, forward propagation, right? So what is forward propagation? Forward propagation is like where the machine actually calculates the output, okay? Now after getting the output, it calculates the loss function as well. Using the loss function, we get the error margin, right? And then after getting the error margin, what we do? We update the weights and again go back to forward propagation. Now this whole process of again updating the weights using the loss function's output is called backward propagation or simply back propagation. So machine learning is all about, the combination of forward propagation and backward propagation, right? Loss function gradient descent okay? So forward propagation gives an output. The output is then compared with the original output using the loss function, and then we come down to backward propagation where it updates its weight, and then gradient descent tells, okay, you are this close to the absolute zero error, okay? And then it again goes back to the forward propagation cycle. So this whole cycle goes around until the machine gets the desirable output or closest to the zero output. Like after a certain point of time, it might be that machine is not moving ahead to global minima, and at that point of time we basically know that okay, this is the best that our machine can perform, our machine learning model can perform, right? Now you might have heard of the proverb, practice makes a man perfect, right? But it's also true for computers as well, that practice makes computers perfect as well. So this whole process, the machine repeats 1,000 or even say 10,000 times depending on your machine's capabilities, because training the whole model for this many iterations requires significant hardware resources as well. So based upon your hardware resources, the machine retrains it itself until and unless it gets terribly good at predicting something that we have given it. And this is how exactly the whole neural networks work. Now there are some technicalities, like technical terms that I actually abstracted from this whole explanation, like activation function and many more are there. I am not getting it into my head currently, but yeah, there are many more such kind of things, activation function and all those stuff, right? Regardless of those, this was the whole intuition of how a neural network actually works. And I would suggest that if you didn't understand in a single go, which is very likely, I'll actually suggest you to rewind the whole video and go through the whole process again, because this is the most layman explanation that you'll ever get of how a neural network actually works, right? Those of you who have understood the whole working, we will from here onwards progress towards a simple code explanation of where I have built a neural network completely from scratch using just mathematical functions. Alright, so let's deep dive into the computer screen now. Alright, so let's start with the code explanation for this whole scratch built neural network. Okay, so a neural network needs to do some work, right? So in this case, I have actually built an MNIST classifier, which is like a dataset MNIST, which is a digit classifier. Like for example, you give it an image of a digit and it will basically generate you what digit it is. Okay, I'll show you how a MNIST dataset actually looks like. Okay, you can actually find this on Kaggle. This is the whole dataset. I'll show you just a second. Yeah, see, so you can see the image right here, right? Just a second. Yeah, you can see these images, right? 98930. So this is how a MNIST dataset looks like, and the computer actually predicts all these numbers individually. Okay, so without using any PyTorch or Python data science or ML library, I actually built this, and this was a blog written by me. Let's say when 21 February 2025. Okay, around 8 months ago from today. Okay, so this was like how I explained the whole process, and I have actually used this blog in my video explanation as well, right? So let's walk through the whole code. Okay, this code is publicly available on my GitHub as well. I'll attach the link to this in the video description as well. You can go and check it out. Okay. So firstly, we go and we basically install all those libraries that we need. We'll need pandas, numpy, matplotlib, pillow. Pandas for data science, numpy again for mathematical functions, matplotlib for plotting graphs and stuff like that, and pillow for image processing because we are working with images after all, right? Okay. Now we import all those libraries that we installed. Import numpy, import pandas, import matplotlib, and import pillow, PIL basically, right? Now we read the data, like the train.csv is just the CSV file. Now a CSV file is a comma separated value where basically you have different values, each separated with commas. This is the whole training data set. You remember I talked about the training data set that you need to first train the machine before you can actually start testing it. So this is the training data set that the machine will actually utilize to train itself. Okay. And we are reading this data using pandas again, right? Now, I talked about pre-processing the data. You remember? This is the part where we pre-process the data. Okay. The data is equal to np_data is like we actually convert the image into matrix values, right? Then we get the rows and columns of the data. The data.shape does nothing. We basically get the rows and columns of the data. Then we shuffle it. Like basically we shuffle it for training and testing. Shuffling as in like we basically shuffle the whole data set. Like 987 was there. We basically do 879. Okay. And then we take some part of the data as training data set and some part of the data as testing data set. Okay. So we basically divide the whole data over here. Like data dev is equal to data from 0 to 1000 columns, y dev, x dev. Basically we are dividing the whole data into training data set and testing data set. That's it. Okay. This is the whole part over here. Nothing much more than that. All right. Yeah. Okay. Now this is the functions that we'll use for our forward and back propagation, right? We took the input. So first level 1 is clear that we have taken the input. Okay. Now the second part is to basically create the hidden layer part, the hidden layer functions and all that stuff. Okay. So we will be doing that over here, right? First we initialize parameters, right? 10 cross 784 is because the images are 28 cross 28 if I'm not wrong, 28 cross 28 pixels, so which results in 784, and 10 because there are 10 rows, 10 outputs that can be given out from 0 to 9. There are 10 numbers, right? So 784 cross 10, that's what basically we will get as an output. This is the whole matrix because 784, 28 cross 28 is the rows and columns, and 10 is like, okay, this many outputs will get. So the total matrix is 784 cross 10, right? Then comes the biases. Bias is like the weights that we talked about, 10 cross 1. This is the weight. W2 is again like a random weight again, and bias 2 is again the biases, the weights all over. Okay. Now ReLU is like I talked about activation function, right? Activation function is like basically it activates a certain set of neurons. Not all neurons need to work together at a similar time. ReLU activates actually a small amount of neurons so that our machine learning model doesn't overfit. Overfit is like you memorize the data. For example, I gave you the table of 2 to learn and you memorized it, and thus you can't basically say what is 2 cross 11. You can only work within 2 cross 10. Only 2 times 10 you can only work till there, and 2 times 11 you actually can't work. So that's what ReLU actually prevents. ReLU is like rectilinear unified unit, something rectilinear unified, some kind of an full form. I don't remember exactly, but yeah, this activation function tells that okay, I don't need to memorize the whole data set. Instead, I need to learn from it. That's what ReLU ensures in short and layman terms. Okay. Softmax is again like basically we got 10 different outputs. Like we will actually get 10 different outputs. We can get actually 10 different outputs from 0 to 9, anything like that. So to map the data accordingly, that is it 0, is it 1, is it 2, is it 3, we basically do this softmax, which actually helps us mapping the output. So is it 0, is it 1, is it 2? That is what softmax helps us in. Okay. Now in forward prop, we basically use a combination of dot functions, ReLU and softmax to get a desired output. As I told you that the whole calculation is done once in the forward propagation, right? Now 1/0 is like, again, basically, mapping the whole output into one single thing. Okay, like let's say the output is something of 0.0075, something like this, and now based on this output we actually need to map it into something. Is it 0, is it 1, is it 2, is it 3, is it 4, is it 5, something like that. This is what 1/0 encoding does. Okay, deriv relu is just like calculating the derivative of the relu function, which is like, I'll have to actually make another video of explaining the whole mathematics behind it. This was a very introductory video, so yeah, please bear with me. Okay, now comes the backward propagation. As I talked, the whole backward propagation thingy, where basically we update the weights using and then we actually see how close are we to the global minima using what we say, gradient descent, and then we again re-update the weights, and again we get into forward propagation. So this is what whole backward propagation is all about, right? And then update params is like updating the weights. Okay, I already told you about this. So this was all about the core functions that will require in the whole neural network procedure. Okay, lastly we start using the predictions part. Def get predictions is just return np.argmax. Argmax does nothing, basically gives the maximum thing, like which is the maximum, is it 0 or is it a2. Okay, then we get accuracy of the model as well, and this is a gradient descent function that I talked about, that it actually tells how close are we from our global minima of error. Okay, and this actually prints what is the iteration, how much loss are we incurring. Talked about the loss function, remember, the accuracy and everything. And pre-process image is like we actually pre-process the image a little bit. I told you about this, that okay, we need to pre-process the image before the machine can actually understand, and that is what we are doing here. Okay, so this is what it looks like. At first we make predictions, we start making predictions, and then we test those predictions. So this is all the iterations that you can see. Like, I have initiated this iteration. At every 100th iteration it will print on the screen, or else it would be too much for me to show to you. Okay, so this is iteration 1. Loss is 14.507 and accuracy is 0.1163. Okay, which is very less, like it's around 11% or something like that, and loss is around very much 14. This loss actually needs to be around 0, as I told you, right? So with each iteration you can see that my loss is growing as well as my accuracy is growing as well. So this says that my machine is actually not working that well, right? My output is not working that well, because we still need to minimize this loss, because obviously I have made this using the bare bones thing, right? Just maths, numpy and all those stuff. So loss that is happening over here is understandable, that okay, I need to minimize the loss and instead use something more appropriate over here. And if I would have done this thing using TensorFlow and PyTorch, this whole thing would look more sophisticated and more accurate, right? But yeah, this was just my attempt of maybe building something that I have learned all the way on my own. I know this model is not accurate at all. Okay, like okay, this is accurate, this might give you good outputs as well, but yeah, this has a very vast loss function, loss margin as well. So I need to minimize and think of something to minimize the loss as well, right? And yeah, just to again remind you, this is how the neural network looks like. Like this is the input layer, these are all the hidden layers, and this is the output layer, right? Again, read this blog as well. I'll also attach the link of this blog in the description as well, and the code as well. I know this code isn't that great as well. You can find dozens of code like this on Google, ChatGPT, YouTube as well. Okay, and this is the MNIST dataset. Okay, so this was all about it. I have tried my best to explain neural networks as simply as I have understood, and I hope it helps you as well. So yeah, this was all about it. In the upcoming videos, I'm thinking to resume my old playlist where I was teaching how to build a computer from scratch. We'll resume that as well. And yeah, this was all about it. So yeah, stay tuned and I'll see you guys soon. Bye bye.